Okay, this is the 1-3C notes reflections across x-axis and y-axis on functions. And I'm going to close this out. All right, so f of x equals negative a times negative bx minus h parentheses plus k. This is our standard form of all functions. Remember, those parentheses act as the function's boundaries. So f of x is what's inside. Everything else are just numbers we're adding to and some symbols we're adding. So the red one is flips across the x-axis. Remember, this means that you're doing a north-south flip. The negative on the B is going east-west flip. So those are the two we're going to focus in on. We've already talked about vertical stretches and compressions, horizontal stretch and compressions, moving left, moving right, up and down. So now we're just going to reflect on the reflections. So making reflections work for you, let's say we have negative x squared. So again, we remove all negatives, positive, we remove all numbers. Well, negative is really -1, so we remove that. And what do we have as our parent function? We have the x squared function, and we put the parentheses around the x to help us to remember that what's inside that is what is references to that equation we talked about on the first slide. Then we apply the vertical reflection because it is outside the parentheses, and that reflects over the x-axis. Well, there doesn't seem to be much of a reflection there. So let's look at one that would be a couple that would be reflections. So we have at the absolute value of x, when we do the absolute value, negative absolute value of x, this one reflects down, that one reflects down. Now we'll do the exponential function of 2 to the x. We have the exponential and it reflects across the x-axis. I put in a dotted line on the x-axis to help us see that reflection line. Now we have the square root, we have the square root, and then we have the negative square root. And again, with square root, this is a limitation of the northern side is the parent function. If we want to see the southern side, we have to do the reflection. Okay. So when a is less than 0, when the a in our function our basic formula is a negative number, that is going to do some kind of a stretch because of the a, but the negative part of it will be the reflection up or down across that x-axis, so north or south. Okay, so here's your your turn. We're going to reflect across the x-axis for this function. So which of these 4 g of x's reflects -9 absolute value of x minus 1 minus 5 across the x-axis? And if you chose that the 9 becomes positive and the -5 becomes positive, you'd be correct. The reason for that is it's negative f of x. So the negative of all of that function, and if we distribute that negative, it changes the functions, but it will not change the power or the operation inside the absolute value because they act like walls preventing anything to be pushed into them. But everything outside of them, the -9 and the -5, both can change their signs. It's what's inside that cannot. Okay, the second problem, g of x is reflected across the x-axis. So f of x equals -9x plus 8. What is g of x? If you chose 9x minus 8, you'd be right. Again, it's negative times f of x. So negative times, put this all in parentheses, -9x plus 8. The negative becomes positive, the positive becomes negative, and that's how you would get that. So making the reflections work for you. Now we're going to look at when x is negative, when we put the negative inside, and this becomes negative b. Negative in front of an x is just -1. So again, if we remove that, we can figure out our parent function, and that is the x squared function, the quadratic. Now we apply that negative to it, and this time it's reflecting across the y-axis. Forget it. Okay, so we have the absolute value of x. When we put the negative inside the absolute value, the solution has to be positive as an answer, but when you put that absolute value in, all it does is reflects across that y axis, so it looks like it doesn't move. But when we look at the exponential, we can see the negative on that x flips it across, and when we do x squared, or square root of x, we see that it flips it across. So it's very clear that we can see it turning over. So reflecting left or right, if b is less than 0, the b will change its size, but as long as b is 1, if it's negative, a negative number, then you will be reflecting across, and it looks like it makes a cross setup. Okay, next. Here is your turn. So you have a g of x is reflected across the y-axis. Remember, what would be the equation then this time? Okay, if you said 4x plus 10, you'd be right. This time it's not affecting the entire equation. It only affects the value connected to x. So in the value connected to x was negative 4x, so that had to become positive. Everything else will stay the same. So when it's going across the x-axis, it affects the entire equation. When it's going across the y-axis, it's only affecting that x. G of x is a reflection across the y-axis of 2x plus 5. Which one is that? Apologize for the sound, phone call. And that is negative 2x plus 5. Again, only the 2x is affected by going across the y-axis. That plus 5 is not affected. When it goes across an x-axis, all the signs get affected unless they're inside a square, the walls of parentheses or absolute values. If they are outside, but when it's y-axis, it's only the x that gets changed. Okay, so a quick recap. A negative f of x is the vertical reflection. It reflects across the x-axis. F of negative x is a horizontal reflection. It reflects across the y-axis. So let's see all of these things at work all at the same time. So we can use Desmos to draw the graph negative 4 times negative 3x plus 4 squared minus 5. So we're going to run through these steps, and these are the same steps that you should do it in an order that helps you to kind of keep everything organized. Always start by looking at your h value. Is it moving left or right? So in this case, it's plus positive 4, which really means minus negative 4, so h is negative. So plus means we're moving to the left, so we're going to be moving to the left, and then we're going to look at the k value, that's up or down. We're going down 5, so we're going to go left 4, down 5. And now we look at the vertical stretch, so we look in front. That is positive 4, which means it's going to get thinner. It's going to stretch. And then on the inside, we look at 3. It's positive 3, so that's, or I mean, it's a bit greater than 1, so that's going to mean that it's going to compress. And then finally, we look at the reflections. It's reflecting across the x-axis and then the y-axis. So let's see what that would look like on our video. So we have our base function is x squared. We take all the numbers out and we get the base function of x squared. We put in our equation, and now we're going to use the base setup to figure out where it would end up being. Okay, so we're going to go to h is 4, and I actually have a misprint in here. It should be minus on there, but it works. But what I'm doing is moving it to negative 4, and then we're just going to go ahead and go through it. Okay, keep watching. So it goes to positive 4 because it's positive 4 here, but it's positive, it's working because of that negative. And then k is negative 5. And then we're going to move a to negative 4. And that is not only going to do the stretching, it's also going to do the reflection. I can't get it to get all the way down. And then finally, we're going to do our 3, which is going to the positive 3 so that we can get that part of the compression. And now we'll do our reflection, which is switching it over to the negatives. And then you see that our purple landed on top of our orange. And again, the dotted lines were there just to help us see the reflection activity. Okay. So now we're going to use Desmos to figure out what is the equation for this graph. We have a graph, but we don't know where the H is or the K or the A or the B. And we're still going to use the same setup, the same steps, but we're going to do it using Desmos sliding system. I really wish I could get this thing to. Oh, I got it. Okay. Okay, so we're going to let Desmos help us. That we have to start out with our basic formula. And again, there's an error here. It should say minus, but it's okay. It will work for our process. So we're going to put in our basic function. Well, this function looks like the the cube root of x. This is what the cube root of x looks like. It almost looks like that, except it looks like it's been flipped over, right? So that kind of gives us a clue what we're going to be looking for. And then we're changing our base function so that it is 1/3, which is the same thing as the cube root of x. And that allows us to be able to see that function being moved and changed, and it will still be in the shape. So we want to figure out what h is. Remember to start with the inflection point. That inflection point on your graph is your hk, and that is the on the parent function. It is the origin. So we're going to start after I get this thing back up to the top. Give it a second. Sorry about this. Okay. I kind of had some faux pas. Okay, so we're going to start by trying to move over to our H so that they're in line with that. So see, it went over to 3, so we know our H is at -3. And then we went to K, we went up to 5. Now, -3 it's -3 because I've had that error at the beginning. H is going to be, should be +3. That's why it's over here. It should have been a negative, so that's why we went to a positive. So just ignore that. And then we're going to take our K and move it over. Now we're looking at A. A is something that looks like it's been kind of squeezed. It doesn't look like it's perfect. So let's try moving it back until we can line up our equation and see if we can get it right on top. Well, it doesn't look like it's a positive, so we're going to look on the negative side, and it looks like it's at -1/2. So not only do we have a compression, a vertical compression, we also have a reflection, and that's why it ended up being slightly squished together and negative. Now, because it landed right on top of it, that means I don't have to find my B. B stays at 1. Okay? And let's see, is there any more to this slideshow? Okay, so let's follow all of the transformation steps for all parent functions. Determine left or right translations by determining if the h is positive or negative, not whether it's a minus or plus sign in the equation. You have to determine, is h positive or is h negative. Where h is positive, you're moving to your h is on the positive side of your number line. When h is negative, it's the negative side. But when you're looking at that x plus h, x minus h, if you're looking at it as just that, then we have to think backwards. Determine if it's up or down, positive k going up, negative k going down. Determine the vertical stretch, compression. If A is bigger than 1, it's a stretch. If A is less fraction or decimal, it is a compression. On our B, horizontal compression, if B is greater than 1, it's a compression. If if B is between 0 and 1, a fraction or decimal, it's a stretch. Then we look at the x-axis reflection, and that is the negative on the A. And then we look at the y reflection, that is the negative on the B.